Sorry? हाँ हाँ Let's start it and then. Hello, good morning. Good morning, Pritam.
Good morning, sir.
I think Manu is not connected on audio yet. We'll get started. So, Navneet,
Sir,
you can hear me now, right?
yes, sir, I can hear you.
Um, I don't know. Manu is not connected. Maybe he, is this demo on? Nothing I can see till now. Demo on? 1 second. Okay, so clearly, can you hear me, Navneet, Preetham?
Yeah, sir, I can hear
Yes,
you.
yes, we can hear you.
Okay. So if you look at this example, this table inventory, okay, inventory and location, this looks like that it has many to many relationship, correct? Did you understand why? So you have product name, multiple product names are getting repeated. So one location will have multiple product and one product will belong to multiple location, right? Oil 5 liter can be in multiple location and Miapur location will have multiple products, isn't it? So clearly this has many to many relationship. So if we have to implement this, we have to create total 3 tables, remember? Many to
Yes,
many.
sir.
So already we have location for table, I mean, table for location. So we don't have to create. I mean, we already have table for location. We have to create 2 more. One for inventory and one for the table which will join inventory and location together. So in this case, we end up creating inventory table. Okay. So we'll call this as inventory. So you will have inventory ID. Okay. Prod name, prod quantity. Not quantity. Quantity is again different, right? So quantity is specific to the location. So the common table that we will create, that will have quantity. Because product oil 5 liter will be different quantity for different location, right? Here you see you have 15 for Miapur, 9 for Banjara Hills, right? So I cannot create quantity here. So quantity is specific to the join between inventory and location. So product name, prod category, okay. And if you want to put price common for all, great. If you want price to be different for different, then again price will also be part of that join table. So let's say price is common for all. Buying price, it will be common. So this becomes your inventory table, and we will have to build another table. Okay, which will be join of inventory and location. So this is your what I'll do is makes sense. We're talking about many to many relationship, right? So this becomes your many to many relationship. Now you have only inventory here. This is your inventory table. This will be inventory location, right? So generally we said that, this has to be multiple. So inventories. Okay, this is what we will call this table as inventories table. Okay, table names are plural forms generally, right? So we'll call this as inventory. So inventories and inventory location. Now inventory location, we will have ID, okay, IL ID. You will have inventory ID. You will have location ID. Now things which are unique. So quantity is unique to it. So if 5 liter, okay, so if 5 liter oil, okay, inventory ID 1, let's say. So inventory ID 1, inventory ID 2, you will have oil, let's say 5 liter. Okay, let's say this is water bottle 1 liter. Okay, this belongs to, let's say, food. This also belongs to, let's say, food. Okay, base price is, let's say, 12.50. Base price, let's say, is 20 or 15. Now here you will have this relationship between these two. Hi Manu. Manu,
Hello, hi. Can you hear me?
I can hear you now.
Yeah, I joined, but nobody was there at 8
No,
eight
your
o'clock.
audio was not connected.
Ah, okay.
Okay. So who has given you this link?
Actually, one of your staff,
One of my staff.
yeah,
Still
in finance,
okay. Okay.
solution.
Okay. Okay. So and you are here for which course?
I'm looking to learn Power BI.
Power BI. Okay. Okay. So the thing is, I don't know, this link that been shared. Again, it's a Power BI course, but right now
Yeah,
we are doing SQL. So
okay.
it's a live class, so maybe you can watch and you can ask me questions, and you can talk to them after the session is done. Okay.
Yeah, that's fine. Yeah.
And your name is Manu, right?
My name is Smriti. My nickname
Smriti.
is Manu.
Okay.
Yeah,
Sure.
yeah.
Great. No problem. Yeah. We'll,
Okay.
we'll go ahead.
May I know your name, please?
I'm Saurabh. Okay. It appears as
So,
Durga. Durga is Power BI faculty. So I'll be taking SQL and then hand it over to Durga. He'll do the Power BI.
okay. So, it will be covered in this webinar or the next one?
Not a webinar. This is a live class.
Oh, this is a live class.
Yes.
Oh,
Yeah.
okay. So it's not for trial.
No, it's not. I mean, yeah, that's what. So maybe what he would have thought is that, you attend this live class and, then you talk to them about things like that. Yeah.
Ah, okay. Okay, that's fine.
Instead of having a
Okay, then.
separate seminar, better you attend the live class itself so that you get a feel
Okay.
what the class is.
Yeah. Okay. No
That's what
worries. Yeah, I'll do
demos
that.
are, right? Demos are for to get understand. Right?
Okay. Okay. Yeah. Thank you.
No problem. Okay. So coming here, okay, so we're talking about inventories table, okay, and here it will have unique product, right? Obviously. But now if inventory, okay, and here it will go on. It's like a normal ID, right? Now inventory ID. Now I'm talking about oil 5 liter. So oil 5 liter has inventory ID 1. So I'm talking about inventory ID 1 and 1. Location ID. Okay, so location ID, this is Miapur 1 and Banjara Hills, right? So we'll go and check in the location table. So location table, Miapur 1 is location ID is 1 and Banjara Hills is 2. So now I'm going to come here and put 1 and 2. So this is how inventories and location is now connected, right? So now I know this 5 liter is sold in Miapur also, and this 5 liter is sold in Banjara Hills also. Okay, and you can give the specific quantity. So here you have 15. Okay, here you have 9. Okay, so as we discussed, okay, it depends upon the relationship, right? So the relationship is many to many, right? Here inventory versus location is many to many. So we end up getting 3 tables. One table for one product, independently one product, another table for independent second product, and third table which will join them together. So in this case, we already have location table. Okay, so we have to create inventory table and then join them together. So now you see how many tables we have. We started with 4 tables, correct? Now we are going to have one more table here. Which is this table? Inventory locations. So inventory location is the 5th table that we'll have to create. Okay, so we'll call this as inventories, right? Okay. So this is how you handle inventory. Now coming to the last one, transactions. This is your bill, right? When you buy something, this is the bill that is generated. So now transaction will connect what? Okay, so this is your transaction ID 1, 2, 3. So let's assume these are your bills, 1, 2, 3 bills. Now inventory sold is something. So this is linked to inventory. So, okay, now again, sorry, coming back here, we didn't shade it, right? So in this case, we'll have to shade these two, right? Because these are your foreign keys, right? So we will add here text. INV ID is linked to inventories dot INV ID and location ID, right? LOC ID is linked to your location table. So locations dot, we'll have to go and get the ID here. So it is LOC ID. Locations dot LOC ID. Okay, so this is how you, yeah. And now obviously here inventory ID will be your primary key, right? Okay. So moving on to the last one. Now you tell me, how do we handle this data? What do you think? Is it one-to-one, one-to-many, many-to-many? If it is one-to-many or many-to-many, then which table are they linked to? No, tell me
Many
first.
to many.
Many-to-many? Many-to-many to which table?
Inventory and employee ID.
Inventory and employee ID, right? Correct. Because on one bill, you can have multiple products, and multiple products can be in, one product can be in multiple bills. So from inventory to transaction, right? So now here you see, okay, transaction as such, okay, will have one table, okay, something like this, okay. Now, okay, so here you see, if you're talking about transaction ID 1, 2, 3, are we talking about each transaction, each bill, or different items in that bill? Now, if you are talking about each bill, not different items, then inventory sold will not be here. Inventory sold will be unique to another table. You getting my point? Yes. So this, what we'll call this as, let's say transactions, right? This is your transaction table. Now, if transaction ID is 1, for example, let's say transaction ID is 1, okay? 1, 1. Because this, you are saying that this is one bill, right? You'll have different products, right? The bill number is, let's say 1, 1, okay? Person, one bill will be done by only one person, right? So unnecessary, what is happening here? This data is repeated. This data is repeated. Correct? So this is not the right way to do it. We have to make sure that details are not repeated. Right? Now, if you call this transaction as, let's say, as I said, right, bill, then if you take this as each item, different item, okay, I call it as 1, 2, 3, 4, right? And then you repeat the bill number. Now also I'll be able to link which product is being sold to which, which product is added to which bill, right? So it's up to you. Again, like we had this employees thing, right? What we said was, not employee, customer, right? I think yesterday when we were discussing about this one, like in a hotel, customer and rooms can be many to many, or customer and rooms can be one to many, depending upon your approach. If you are not bothered about customer, you don't want to track if customer is coming second time or third time, right? Most of the normal hotels, they are not that much worried about customer. right? In the sense, if you go second time also, they don't, they don't know and they don't want to know whether you are here for second time or third time. But if you talk about 5-star hotels, they have this loyalty point. So for them, they need to know if you're a customer. So in that kind of hotel where they want to track each customer's detail, it will be a many-to-many relationship. But hotel where they would not worry much about customer, right? If you go second time, you are like a new customer again to them. In that case, it will be one-to-many. Similarly, okay, if I come back to transaction, and transaction, I'm not worried about having, see here you're repeating this, right? Like bill number 1 is repeated multiple times, Virat. Now, the transaction as such will not have much of complexities, right? Because you are just linking your product to the bill number to employees. So in this case, I can go with one table, okay, where I can link this to employee. So what is Virat employee ID? 2, right? I can simply go here and say employee 2, 2, 2, 2. Okay. Bill number is 1, 1. And here also, instead of talking about inventory sold, I'll just give the inventory ID. Okay. Inventory ID is 1, 3, 2, 4, let's say 5. These are the inventory ID. Okay. And then quantity sold. Okay. You can have different. Now, in this case, okay, this is good enough. We are repeating employee ID, but here we are not repeating multiple information, right? So in this case, though it is many-to-many relationship, okay, but what are the base table? Base table is inventory and employee, which is already created. So this is your third table. See, as you said, correct, this is many-to-many relationship. In many-to-many, we need 3 tables. But the 2 tables that we're talking about is already created. Which are the 2 tables that is making it many-to-many? Inventory, correct? One bill will have multiple inventory, and one inventory can get into multiple bills. One employee can handle one transaction or multiple transaction, okay? But reverse is not true. One bill will have only one employee. So with transaction and employee, it is one-to-many. But transaction to inventory is many-to-many. Does that make sense?
Yes, making sense.
So transactions to employees, okay, it is one-to-many. One transaction will have only one employee. No 2 employees will come and do the same billing. So for transaction to employee, it is one-to-many. Okay, but transaction to inventory, okay, is many-to-many. Because one transaction can have multiple inventory and one inventory can go to multiple transaction. So this transaction table again, okay, will have employee as foreign key, which will link it to the employee table, and inventory as a primary key, which will link to the inventory table. Right? So if I go here, insert text box. Okay. So INV sold is linked to inventories dot INV ID. Is that right?
Yes.
And I'll call this as EMP ID or AEMP, or let's have employee, doesn't matter what name you give. So employee is linked to employees dot EMP ID. Okay. So this table is behaving 2 different relationship with 2 different table. Right? Now you can ask me, right? If it is many-to-many, then where's the third table? Inventory is 1, transaction is 1, where's the third table? Now, In third table, okay, I'm in third table, you're only linking the bill number, right? So instead of like, if you do not have multiple information to see, why are we doing third table? Because there could be multiple edits, right? What we said was, in database design, you have to design such a way that if you have to make edits, you don't have to make edits at multiple places, right? So if I take the previous example, here if quantity, okay, has to be in third table. Okay, now if I have to change the description here, if I have to change the description here, I will, if I put them in all in one table, then I'll have to change it multiple places. But in this case, in transaction case, we do not have anything other than bill number. There's no other information. So you are not duplicating it anyways. So here transaction is good enough for us to handle both bill number as well as inventory sold in one table. That's why we are not creating another table. But again, if you want to make it, you can make bill table separately. Bill table separately, because now say here, if I have bill number here, this is just bill number, but I want to capture bill date, bill time. Okay. If bill has multiple characteristics, then better that you create separate bill table. Okay. Here I'm just capturing bill number. I don't want to capture date, time, and other details. Then it's fine. But if you want to capture other details, then you can have another table. Okay, let me put it here. So also depends upon how complex is your data representation, right? If data representation is simple, I'm not creating a new table. But if data representation is not complex, okay, then you can put them in same table. But if data representation is complex, then what I can do is I can create one more table here. Okay. And I will call this as bills. Okay. And I will have bill ID, employee ID, date with time, date time I call it. Okay. Where is it? Sorry. Okay. And you can have more characteristics. Right? Now, in this case, then I don't need to have employee ID here, because employee ID is already done here. So let's say bill ID 1. It's not allowing me to edit. Okay. Bill ID 1, bill ID 2, bill ID is done by employee ID 2. Bill ID 2 is done by employee ID 1, let's say. Now, in this case, I can get rid of this table. Okay. And I'll have bill ID. So now you know, okay, that this is done by who? I can link this to transaction table or bill table rather. So your transaction will come here and okay, let it be here. This is what description, right? So this becomes your bills table. So it depends upon how complex your data can get. If bill is complex, it's better that you treat bill separately. Okay. So now in this case, inventory sold is linked to inventories and bill number, not employee number. Now employee is linked to in case of bill here. And in this case, it is one to many. One employee will have only one, one bill will have only one employee, but employee can have multiple bills. So this becomes one to many here, and this is here, then you will have bill number. Earlier, we included bill number and employee same here, but now we have a different bill number is linked to bills.bid. So we have to break transaction into two tables in case you want to capture data, bills details. I want to capture bills detail. So I have created a different table for bills and different for transactions. So now, how many tables we have? 6 tables, right? And this is your bills. Okay. So, okay. So now we have understood the structure of the database. Based on what we started with, we have understood how database is created. Now, this is the job of database designers. Okay, we don't get into so much of detail, but we need to understand how these are done. Yeah. Now the question comes, okay, the ER diagram is entity relationship. So we have already created entity. Entity is your table name, and relationship is the connection, one to many, many to many. One to one, anyway, there is no connection. One to many will have link, or many to many will have link. Now we have to represent this entire relationship in one single screen. That is ER diagram. It's a diagram, it's a pictorial form, it's a visualization which represents the entire database relationship in one single visual. Okay, so let's start here. Employee is not linked to anything. Okay, so we can move on to the next one. Location. Location is linked to employee. So location, okay, what we'll do is we'll just change the position. Okay, I'll put location here so that it becomes easy to manage, right? Okay, so location is linked to employees. Okay, so this is your relationship. What kind of relationship is this? Huh? One to one will have then we will same table, right? Yeah, it is one to many, correct? Okay, one which side, many which side. One employee will belong to only one location. But okay, sorry, multiple employees belong to one location. But one location will have multiple employees, right? One location will have multiple, but from employee perspective, we look at only each employee will have only one location. So in this case, it becomes one here. Okay, so you will have one here, and then you will have many here, M here. So one employees will have only one location. But if you come from location, this side, it will be many to many. Okay. So we write like this. Now, in fact, transaction should be down, okay? Because we are talking only about these 4 things, okay? And these 2 are byproduct of creating these 4. So, okay, employee to location done. Then inventory. So we are saying inventory, okay, inventory has many to many relationship with location. So your inventory and location. So again, you will come up with a line here. And it is your many to many in this case, right? Now talking about bills, right? So bills has one to many with employee. Okay, but many to many with inventory. So main is inventory. Transaction is byproduct of inventory and bills. Okay, so we say inventories will have okay, I can do it from here. Not sorry, not inventory, bill, right? So bill has okay. Now in this case, if you see, employees can have multiple bills, M. But reverse way, if you see, this is going to be only one. To bills to employees is one to many, employees to bill is many to one. And now bills to inventory is what? Many to many. So this is how you write your ER diagram. Your inventory location and transactions, these are byproduct of doing this relationship. Okay. So, we don't represent this in the ER diagram. Okay. Because ER diagram is about designing. What we did here, just to explain you, we have gone through the table, described the table so that now when I talk about these, you're able to visualize. But in reality, what happens? ER diagram is created first and tables are created afterwards. So ER diagram is done by architects, who has a lot of experience in database. And then based on ER diagram, even somebody with basic knowledge can also create tables. Okay, so ER diagram has relationship and also we call them attributes. Attributes are nothing but the columns that we spoke about. So attributes are represented as oval shape. Okay. So these are attributes. Every entity will have multiple attributes. Okay. So later it becomes column. But okay, it is attribute here. So all the column names should be added here. So this number of attributes same as number of columns that we do. Sorry. So ER diagram talks about entities, relationships, and attributes. Okay, the attributes are also connected like this. Okay, attributes are connected like this. Okay, so here you have ER diagram has entity, relationship, attributes. Attributes become columns in the table. Okay, entity becomes table. Relationship is either, so relationship can also become your table or foreign key, right? So if it is many to many, then relationship becomes a table. Okay. So let me make it a little smaller. Okay. So relationship becomes a table in M2M and foreign key in one to many. So the good design, okay, what good design does is it breaks all M2M. It breaks all to M2M. Okay. Now see, yeah. So this is one M2M, right? So this we break and instead we add transaction here. Okay. All M2M relationship should break. All M2M relationship should break. Now let's look at this. Bills to transaction. Bills, sorry, inventories to transaction. Okay, what will happen here? Which side is 1, which side is M? You understood? All M to M should break. And this is where you will have new tables coming in. So if you look here, bills, one bill will belong to only one transaction? No. Multiple bills belong to one transaction. Right? See the table here. Bill 11111. But reverse, one transaction will have only one bill. One transaction will have only one bill number. So it becomes multiple and one here. Similarly, transaction to inventory. One transaction will have only one inventory. But when we have inventory, multiple can belong to transaction. So it becomes one to many. Similarly here, again you break this and add this new table. And now we talk about okay, so we will add here till here. Okay, I think I should move M up. This is getting linked to M. This should not be linked to M, but to this here. Okay, we'll move this little up. So originally what we had was our plan. But when we started implementing, we had to introduce two new tables to break that M into M, many-to-many relationship. Many-to-many relationship cannot be implemented in good database design. So I have to break it into one-to-many and one-to-many, many-to-one, basically. So now it is one-to-many. Here also, if you do it is one-to-many and many-to-one. Okay. So this is our final design. This is what we need to now implement. Once you do this, then implementation is very easy. Okay. So we'll stop here today. Tomorrow we are not meeting. Okay. Tomorrow I have a PhD Viva. So I'll not be there. Monday we will connect. Monday when we connect, we will first look at different data types and then we'll look what? Create table and we'll also install MySQL. Okay. So job is to install MySQL and we will look at the code, okay, to how to create table. You will have to go and create table by Monday evening. So Tuesday when we connect, you should have all the 6 tables in your MySQL database. And then we will see how to add data to the table Tuesday. And hopefully from Wednesday, we'll start querying the table. Any questions so far? If not, we'll end it here today. We'll see you on Monday. Okay.
Okay. Thank you. Thank you so much, sir.
Thank you.
Bye, everyone.
Bye.